All right then, shall we move on? If you'd like to, well, that's your choice. I can start talking about materials part. All right, so polymers is the first part, and there are only what 3 subtopics in final chapter, and everything in this chapter is the application of what you've learned so far. Heavily, polymers is heavily on the organic chem that you just finished. But yeah, it also covers some environmental facts as well. So yeah, and the application of everything that you've learned really. Okay. All right. So intended student learning again. Discuss the advantages and disadvantages of synthetic polymers, as you saw yesterday in the factory. Identify the repeating units of polymers given the structure formula of a section of a chain, very similar to protein that we've already done. Identify a polymer as being the product of an addition polymerization or condensation polymerization given structure formula. You've already seen one yesterday in front of you. Draw the structural formula of an addition polymer that could be produced from monomers containing one carbon-carbon double bond, or given the structural formulae of the monomers, vice versa. Second page of that. Identify the ester link in the polyester and the amide link in the polyamide. Next one, draw the structural formula of the polyester or polyamide polymers that could be produced from monomers given the structural formula of the monomers and vice versa. Third one from the bottom, describe the effect of rigidity of increasing the number of primary and secondary bonds between polymer chain. Again, hopefully you saw that happening at those 2 factories of plastics. Describe the effects of heating on thermoplastic and thermoset polymers and a consequent difference in ease of recycling. Yeah. So you see the point of view going to those factories. Finally, describe the advantages and disadvantages of fillers in polymers. All right. The first slide there is really an introduction of what polymer can make. A lot of the things that you see are polymers, in fact. The smallest from DNA to silly putty, something that was created accidentally. There's a video, but we might skip that for now. Yeah, you watch that in your own time, I guess. Large molecules or ions that can consist of many distinct units linked together by covalent bonds. So macromolecules that you have been learning in bio, I guess, they are all type of polymer too. And this person, Hermann Staudinger, Nobel Prize winner in 1953, found a polymer chemistry. So polymer science was not really understood before then, but now we know a lot of things that makes up us, our body, content of our body, or things that you see in front of you, like wood or tiles, stones. A lot of big things, they're all, polymer. That's how it's understood after that. 40% of all chemical production makes polymers, because we deal with something that we can hold, or something bigger than that, wouldn't we? All life is based on polymer: DNA, RNA, protein, starch, cellulose, Okay. There are mainly 4 types of polymers though. Firstly, fibers such as cotton, which is cellulose, wool, nylon, and silk, which is protein-based. Plastics such as plastic bags, paints, Danish shoes, the plastic film and hard solid, which can be molded into shapes, so plastics. elastomers, which are stretchy and bouncy polymers like rubber, and finally adhesives, glue. They're all types of polymers, but there are four main different types of polymers. Now, the polymers, they have wide range of properties. If it's glue, it's going to be sticky and it can bind things together. If it's protein based, that does make our lives possible. It is also possible to synthesize a polymer with properties that you like. This is achieved by controlling features of polymers' molecular structure, such as chain length, extension of branching and cross-linking, and polarity of side groups. Okay? So depending on what size they achieve, depending on how well those chain of the carbon is connected with each other, you can change rigidity, stretchiness, bounciness, and so on. Okay, so you can purpose make the polymer depending on what you want. Adding substances to enhance properties of a polymer, like UV absorbers, plasticizers, and dyes and fillers. Synthetic polymers, they have in the world now have replaced many traditional materials in a variety of applications. For example, PET, a lot of water bottles, PET bottles, polyethylene terephthalate, they are now used for soft drink bottles. Nylons, polyesters, a lot of clothes that you wear now would be made out of that. P uniform is polyester, I think. Nylon, a lot of shoes. Polymers, they have also replaced glass in glasses. And many car components are made from polymers now instead of metals in the past. Polypropylene, PP, is the short form that you see on some plastic materials. They're used to make artificial grass, electric kettles, garden chairs, disposable nappies, margarine, CD cases, or something that's a bit more durable. And newer types of synthetic polymers include polyethanol, used to make plastic bags, which dissolves in water. Hydrogels, its polymer comes in like plastic, pretty hard ball, but if you soak in water for one night, they grow, they absorb water and release water slowly. So very good for plants, and especially in dry country like here, having those hydro bowls is very good, very cheap too. But I bought like 2 liters worth of bowls for my garden before, and it's releasing water in summer very, slowly. Kevlar, how do you know that? Have you heard of that? Kevlar vests, blade-proof vests. It's got plastic in it.
Are those like bead things though? Wait, no, it's not.
Kevlar, no. They're very strong, but because it's plastic, it's much lighter. So instead of having like steel plates in front of your, chest, it's much lighter option for you to have Kevlar. It absorbs and it doesn't break, so it absorbs shock and it doesn't break. So good for vests or making gloves, which allows you to hold onto a knife, grab a knife even.
Is that those like silk gloves? No, they're chain, but they're still gloves. Yeah, but there's some like very thin.
It does the same thing. Would do the same thing, but it would be much lighter because it's not metal, it's plastic, and can be quite thin as well.
Would it hit as hard as steel?
Is it? You're asking or?
You got a Kevlar ball.
Yeah.
And like steel ball. You throw a steel ball at someone, and before you knock them out. Do you reckon you could do the same thing with your bubble and be lighter?
Too light.
Yeah, sure.
I think it's too light.
Could you stop with the wind? Do you
Too light.
I think it's gonna be too light.
reckon? Okay.
Yeah. There are a lot of synthetic polymers. Mr. Morrow, he was telling me about this paint that he used to sell. That's also polymer. That protects the surface of car, which doesn't break at all. It might damage the internal part of it, but it doesn't affect the shape of the car itself. There's a video I should show sometime soon. The Verterism video clips. They put this paint on watermelon and drop the watermelon with this paint on to the ground from like 50 meter high and doesn't break. Hey?
Does it bounce a bit?
Yeah, it just bounces off, and internally it's all crushed up, but the paint layer doesn't break at all.
So it's okay if your car gets completely smashed, but if your paint's okay.
Yeah, that's right.
We should experiment with a car from 50 feet up.
Alright. Now, a lot of these polymers, which replace the traditional material like wood
Lift it up. Too light.
or paint, a lot of paint in the past used to contain lead, which was toxic, and old houses, you still, when you're scrubbing the paint off, you still need to wear masks to protect yourself from lead to be absorbed. Compared to that, nowadays paint, acrylic paint especially, they're so much cheaper because it doesn't use heavy metals apart from titanium oxide, which makes a white pigment, which is harmless. Polymers can be created for specific use, and properties can be altered accordingly. So hard, soft, whatever. Additives can be included to further modify properties. So if you already have, polypropylene, okay, which is already a fantastic material, but if you add few things, add some colors, you can make into synthetic grass. You could make that into much softer or much more rigid, like rope or other applications very easily. Disadvantages. What you can see there is that the raw material for most organic polymers, they are crude oil, so non-renewable. Yeah. So we're using non-renewable thing to make our products, and once we make them, most of them are not biodegradable. So you can see the bird carcass there having a lot of bottle caps, and see those. What do they eat? They eat jellyfish. But yeah, plastic can look like jellyfish underwater, so they would
On purpose.
go and eat them. Now, if the plastic is like plastic bags, they are fairly easy to break down to smaller chunks. When that happens, they don't actually get digested. They don't become small enough to become harmless. They actually start reaching some toxic components out, which is not good for wildlife, of course. So additives like benzene can come out, toxic. Sulfur can come off, toxic in a lot of amount of it. Combustion. A lot of third world countries still do this. Like if you have got tires, they are now here converted into like small chips of rubber, and you see them on the ground of playgrounds. The small chips are made into like big slab of it, so that's a the shock absorbing material. So those things are good, but like if you go to third world countries, you still see mountains of rubber still burning, tires still burning, and environmental ministers over there do nothing about it apparently. Still happening in my wife's hometown. So yeah, as you can see, lots of plastic waste is still there. And in the future, I would like to be able to solve some of these issues by using my knowledge and making my wife's hometown better. So I would like to be a cleaner one day. All right. Compounds of high molecular mass composed of a large number of relatively simple molecules, which are called monomers. They are joined together by covalent bonds in a polymerization reaction. So that's pretty much how all polymers are made up. Okay, whether that uses different types of mechanism or the reaction. Okay, it all starts from monomers, and you join them together somehow. Right? That's really what polymers are. If I didn't say, poly means many, mers mean parts, so many parts. If you are looking at monomers, only one part. Yeah. If you have got one monomer A, many monomer A, you can just join them together to make polymer called poly A. And repeating unit is another terminology that's given for when you look at polymer. Repeating unit in this case is A with two bonds coming off, and you put just N next to it. That's a convention that you can use for any polymer. Okay? If you can identify monomer unit or repeating unit, okay, just put two lines coming out as bonds and put N next to it.
So would that be, so like N, would N be 9 in that top example sort of?
Yeah. That polymer chain that we have there is only 9, but N is usually used. Because usually it's very hard to control the length of the chain when you're making polymer. Yeah.
So would that A could be like any like compound or element?
Yeah, any monomer that you start with. Yeah. Like for example, if you start with glucose and then make starch out of it.
So it'd just be glucose in square brackets.
Yeah, glucose with two bars coming off. Yeah. And the monomers are different can link from to form a polymer with an alternating structure. What it's talking about is that if you have got monomer A and monomer B, so two chemicals mix them together, heat up or whatever, and you get the structure like AB, 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 repeating structure. That's also very possible. Okay. Repeating unit in this case is AB has a repeating unit, and number of them would be there, so N outside the square brackets. Let's do a practice. You might have an answer already there, but let's not look at the answer. So if you have got these examples of polymers, where would you be able to say for A is the repeating unit?
The C2 is where it starts and the O is where it finishes.
Okay, maybe you can say that.
I mean CH2, sorry. Yeah, you got me. Yeah.
So you are saying before CH2 10, you put the beginning, and ending would be just
the O.
before.
Yeah.
Just before the next.
All right. Okay, you could maybe say that.
It's wrong.
Oh, is it? Okay.
When you look at the monomer unit, though, what do you think the monomer could have been?
The CO. And like the double bond.
Yeah, CO double bond could be one end, and the other end would be
The HM.
HN. What do you call that monomer? Say that again? Yes, well, amide is what's made. But if you have a component which has carboxylic acid and amine group attached to it, what do you call that thing? This is going to be tested in the organic chem, right? Organic molecule which has got carboxylic acid and amine, what do you call that?
Carboxylic
Amino,
acid. Amino acid.
Yeah.
So it's
amine and carboxylic acid, yeah? A molecule which has amino group and acid group, amino acid.
that makes sense.
Yep.
Yeah.
And if you have got many amino acids, yeah, and then they're repeating, so monomer unit in this case needs to start, say, in between that amide group, right? So say before CO and NH, after NH, that should be, there you go, the repeating unit. Okay, so you need to be able to apply the knowledge of, you know, what you learned in proteins and amide group. Oops, I shouldn't have done that, but oh well. This one's a bit simpler. So anywhere could have been okay, but CF could be the start and then ending before CF2.
Would it make a difference if you just did it like starting at O and ending?
Not in this case, no. First one was much clearer. Second one, how this polymer was derived is less clearer, so it's okay to be anywhere. How about C, third one? Where would you put the brackets?
Before the ketone group.
Before the ketone group,
And
okay.
then after the nitrogen connected to the.
Yeah. Okay.
Is the far right at the end of it? Because there's no line coming up.
Yeah. Oh no, CH2 it says, so it must be still continuing.
Okay.
Hmm.
So in that scenario, just because there's not a line coming off it doesn't mean it's the end.
No.
Okay.
Like this oxygen will still be continuing. Silicate.
Yeah.
Wait, are we talking about C? Or
Yeah, C. Yeah, CH2.
Wait, does it matter?
It's got one more polymer
Yeah.
somewhere.
Doesn't really matter which if it's the ketone that starts or if it's because it's the same, isn't it?
Not really, no. But where would you start the bracket and where would you end?
at the first
end.
end and then to the second end?
Yeah.
After the ketone.
After the ketone.
Yeah.
I think that's better. Yep. So this monomer unit seems to have 2 nitrogen in it. I think that is correct. All right. How about D? Now this is what you will see in silicate subchapter, so third subchapter. What's a monomer unit? Where would you start? Where would you put the closing bracket?
Started at the start after the O.
Yeah?
Start here.
Yeah, that sounds fine by me. Anywhere is fine, just before oxygen. And if you start before the oxygen, make sure you end before the oxygen. Yeah. Or after and after.
Yeah.
Doesn't make
As
much.
long as it's consistent.
Correct. Yeah. How about last one? Phosphate. Polyphosphine. Is that what it's called?
After the
So if you start after what?
after the oxygen.
After the oxygen, yeah. Where would you put the
There's so many
closing?
oxygens.
Yeah, any oxygen is fine.
Yeah.
If you start after,
And
then
super consistent.
you need to also end after, yeah? So anyway, it's fine. Now, some people get confused that, hang on, this part and that part looks very different.
Are they just split?
Yeah, it just
Yeah.
flipped, yeah? So monomer unit is still the same, but next one is just flipped around and that continues. But in terms of molecular formula, that's still the repeating unit, yeah? Okay. Couple more minutes. I'm halfway only. Oh. All right, reactions to form polymers. They are classified as usually addition or condensation, polymerization. So addition is fairly straightforward. You add the monomers and you achieve polymer. Condensation, I hope you're familiar with the term already. You are condensing, so taking water away from it. Addition polymers, they occur when unsaturated cyclic molecules add together without elimination of a portion of the monomer molecule. Okay. The reaction conditions may include heat, high pressure, and a catalyst to initiate the reaction. Second dot point is more important, I suppose, because we'll be looking at some examples next. All right. For example, I think I talked about this in ethene part, or even last year. So if you have got carbon-carbon double bonds, yeah, one of the bonds can break and grab another carbon. And if you have many monomers of things like ethene, CH2CH2, or C2H4, then they can have one of the bonds break up, and then that happens everywhere else to make the polymer. In this case, though, is there brackets? Yeah, there you go. So repeating unit in this case, it looks like CH2 is the only the monomer part, but because you started off with ethane, the repeating unit needs to be CH2CH2. Does that make sense? And the molecules of addition polymer usually consist of a chain of carbon atoms joined by single covalent bonds. Remember the conditions needed for this reaction to occur? What do you usually need? Heat, high pressure, catalyst. Yep. Usually nickel is used, just like saturating the unsaturated triglycerides. Yeah. The monomer structure is the same as the repeating unit, but the carbon to carbon single bond is replaced by carbon-carbon double bond. All right. Can you draw the structure formula of the monomers? You'd probably have the answer there too already, but oh well. So hopefully you could at least tell the monomer unit. If you have got this as a polymer, so start the bracket before, and start the bracket before here again. End the bracket. End the bracket should be put before next carbon there. Yeah. So here, CC double bond with benzene ring is a monomer. So where it started, we'd have looked at that. Very similarly, carbon-carbon, and then CN, so cyan or group is attached too. We will probably end it here. We will talk about condensation polymers.
So you not put the double bond there?
Sorry?
Like, back, anyway.
Yeah?
It's the double bond between the two C's.
Mm-hmm.
And all the C's there. So you don't have to put them in.
So again?
So the double bond is between the C's.
Yeah. So originally it could have been here or here, either way. Yeah.
Just there, so there's no double bond on there.
Or here.
Yes.
Because double bond used with one bond is consists of two electrons. Right? So what those electrons open up.
Say how close to the finger. Being saturated.
Yeah, that's right. So it used to look like that because one of the electrons will come over here and one of the electrons here will come over there. You will have, I should have pointed this. See, only single bond left, and there will be electron here and there. And if there was many of them,
Ah, okay. So by itself, it's got a
yeah.
double bond, but
So it will try to bond with each other. Therefore, you will get polymer afterwards. All right. We'll continue tomorrow morning. We should be able to finish polymer part tomorrow then, which is good, if you can. All right. See you tomorrow morning.
Ryan and Jai's. Some of them are very similar. I think the rest are fine. But yeah, Ryan and Jai.
You can be going later. And Ryan getting higher marks is a concern. These
Yeah.
ones,
The-
yeah, it's very
Jai
hard.
didn't do that one, but
Okay.
Ryan did.
Okay.
But it's mainly in the observations, like it would be the exact same. Not produce some images.
Can't really prove that they do.
But it does, yeah.
They made like same mistakes here and there.
They made the same mistake with that one, but that's just the product, so that could have just been like discussed.
Well, that part is very hard to prove. Only if they both did this and
I mean, it puts Ryan on a D minus still.
yeah. I would have probably just went with it.
Just let it go. of it.
Yeah.
Sky did well.
Sky did well.
Okay.
Okay, good.
Yeah, that still puts her in a C plus since he didn't do well in the first half.
Yeah.